Welcome back, Flare community. I hope you're all well and having an incredible day as always. And yes, we are in for a treat today. It's going to be all about Flare 2.0, and this is going to be a live stream that is focusing on this X space here. So if we go over here, this is the Flare official account at Flare Networks, and we're going to be talking here with Hugo. Filion, we've got Dinesh, who is going to be leading, and also a co-host, Mr. Dan Rocky. So what's going to be talked about? It's going to be all about Flare 2.0. And if you haven't found out about this, it is very exciting. Connect, compute, and conquer. Flare 2.0 begins. Unify chains with unparalleled cross-chain execution, boosted compute abilities, and enshrined data systems. Do more with decentralization. So this is actually very unique for the Flare network, and it takes things to the next level when it comes to interoperability. People are going to be able to use wallets that can execute from the Flare network transactions on other chains, and this is extremely powerful and extremely exciting too. Flare team did release this post here, expand Flare consensus across chain. So let me just read a little bit of this while we're waiting for things to get started with the X space, and we'll go from there. So the core promise of a smart contract platform lies in providing a global distribution layer for financial products, empowering users to transact without reliance on intermediaries or the fear of censorship. And this is very much the foundation of a blockchain. One of the biggest benefits is being able to transact peer-to-peer without having to rely on a third party. You know, if you're sending value between banks, you have to rely on the banks. But with blockchain, it's peer-to-peer, just powered by a network of computers that are running software which actually create the network. However, since their inception, developers have struggled to create applications that match the functionality and user experience of Web 2 apps. Just briefly here, Web 2 refers to the traditional applications that you may be familiar with. Maybe it's a social media network like X or Meta, Facebook, Instagram, or whatever it may be. This is considered Web 2. Web 3 is the evolution where the Web3 applications are utilizing decentralized technologies such as blockchains. This is mainly due to the computational limits and siloed nature of smart contract platforms, which constrain what developers can build safely. As a result, while digital assets have gained traction as an asset class, the range of on-chain use cases remain notably limited. To drive the industry forward, it is essential to expand the possibilities developers can achieve through their code. This expansion will be enabled by seamless cross-chain execution, high-integrity data from both Web 2 and Web 3, and substantial computational abilities. Critically, these aspects are most valuable to users only if decentralization is preserved in building out these capabilities. So let's carry on. We've got about 5 minutes till it starts. This article explores how trusted execution environments, also known as TEs, integrated with Flare data protocols, enable protocol managed wallets. And this is something that I'm very excited about. These are a system that allows protocols built on Flare to execute cross-chain transactions directly while preserving decentralization, trustlessness, and freedom from censorship. Additionally, the synergy between trusted execution environments and Flare's data protocols introduce T-compute, or verifiable compute, which will be explored in the next post in this series. Here's a little diagram for you guys. So we've got Web 2 here. We've got the FTSO, the Flare Time Series Oracle, and the Flare Data Connector, which relays back and forth and validates data from the Web 2 world into the Flare network. And you can think of Web 2 data maybe as a sporting outcome. Let's say your favorite football team has won a match and there's an application that relies on this data. The Web 2 data can be fed through the FTSO and the Flare Data Connector, be verified by the infrastructure that we have, various attestation providers, onto the Flare network, so you know that it is true and it is of high integrity. You've got the verifiable compute, which is a layer which can obviously interact both ways between Flare and this particular layer. You've got the Flare Data Connector, which can link to all of these other blockchains. Here are some that we have here. We've got XRP, Ethereum, Dogecoin, Bitcoin, Solana, and Base. I'm sure this is just a small sample of what is to come. And the protocol managed wallets. And this is something that I'm particularly excited about. Consensus assigned data goes to the wallet and executes. It's executed according to the Flare consensus. Who's Crypto? Are you saying that the stream is glitching, or anyone in the comments, please let me know. I'm not sure if there's anything that I can do about it. It may just be that my internet is a bit slow today. 3 minutes until we get started here. Let's have a look. Oh, perfect. Cheers, Hughes Crypto. Glad to see you here, along with everyone in the chat. We've got Property Rich. What is a vision if you cannot complete step one? Well, I would say that step one has been completed long ago, that being the launch of first Songbird and then Flare. You know, I think a lot of people do get impatient with anything that's happening in the blockchain space, but I think a lot of this is geared towards F assets, which have obviously taken a long time to come to fruition. But in order for F assets to have launched, there needed to be a huge amount of work that needed to be done prior. Without the Flare Data Connector, without the Flare Time Series Oracle, none of this would be possible. And these protocols are not possible unless there is a vast amount of data providers and attestation providers that can support these protocols. So it's just something to note. Oh, here we go. It looks like the party may have started. Let's quickly check in here. It did just go live a second ago. We've got 1 minute until the designated time.
Hey everyone, welcome to our Twitter space. We're just waiting for another guest to join, and we'll get started in just a few seconds.
Well, there we go. That guest would be Hugo Filion, if I'm not mistaken. I've just turned that down just for now. I'm going to wait till we see Hugo up in the screen here, and then I'll maybe shut down the my chat, and we can listen in. See, Hugo's joined here fashionably. I was going to say fashionably late, but he is still 1 minute early. I'm sure he's going to get dragged up onto the stage, and then we can listen to Flare 2.0, the vision, the deep dive with the main man himself, Hugo Filion. So, pretty exciting time. I'm probably going to break down this paper in a little bit more detail because it is pretty expansive, as I'm sure you can tell. There's a lot of things that are introduced here, and this is probably my favorite aspect of it: protocol managed wallets. Just to summarize again, it's going to allow you to manage transactions on various chains from the Flare network and leveraging the consensus algorithm and all of the infrastructure that Flare offers. Right, Hugo is on stage. I did just listen to him then. He said about 1 minute, we're going to get started. I imagine that they're waiting for the room to fill up here. Wow, Who's Crypto in both YouTube live stream and here on the space as well. So, right, I'm going to head out now. It looks like they're just about to get started. So let's listen in and feel free to comment and we can have a chat in there.
Good to be back here on X Spaces with Hugo. And also today we have Dinesh with us. And yeah, it's a really exciting spaces, this one, and I think I'm lucky to have the honor of hosting some of these very interesting X spaces. So yeah, and I guess I'm Dan Rocky, and as I said, I'm hosting the spaces, and yeah, but let's jump over to Hugo. Hugo, you want to say a few words?
Yep. Hi, everyone. Thanks for joining. I think we put out a piece last week, which was the first part of what we're calling the Flare 2.0 vision. It was specifically on a protocol that we're building called Protocol Managed Wallets. This Spaces is going to focus mostly on Protocol Managed Wallets and what they can do, but with a little bit on the overall vision. So that's kind of where we're going to start today. I'll let Dinesh introduce himself.
Hi, everyone. I'm Dinesh. I'm the technical product lead at Flare, and my background is in physics. I did my PhD in quantum computing, and I'm also a dev, primarily focusing on Python and Rust.
Great, awesome. All right, so so let's just go through the rundown. So today we are going to talk about Flare 2.0, the vision. We're also going to look into the trusted execution environment and understanding this a bit more. Then let's have a closer look at also protocol managed wallets. I'm sure it's something you all are very interested to hear a lot about. And then we move on also to talk about the Flare Google Cloud Hackathon towards the end. So, but let's, yeah, and if we have time, I think we already did collect a lot of questions from the community that's basically lined up. But if we have time, we will also end the spaces today with questions from the community. Yeah, that you can leave in the comments. All right, Hugo, but maybe you could conclude on some of your thoughts with respect to your Flare 2.0 vision, and you know what are the some of the issues that you're trying to solve with Flare 2.0?
Yeah, absolutely. So I think, I'd start like going back and say, why does Flare exist? Why does Flare 2.0, why is that a thing? And I think like fundamentally there's something broken with how blockchains work. There's basically 4 products, 5, a couple of products in blockchain, 5. There's staking for security, there's automated market makers, there's lending, there's perps, there's payments. Beyond that, there's like very little other real product that gets traction in blockchain. And one of the things that I've noticed is that traditional finance has way more products, way more products. I mean, for a start, they have proper options. which we don't have in blockchain. So, we've been thinking a lot about, why, if you just take out the financial part, blockchain is fundamentally an internet technology. So even in the thing that people care about for blockchains, which is finance, we only have a few products. And then if you think, well, okay, but this is an internet technology, we should be doing more with this technology that isn't just finance. Why aren't there breakthrough products in blockchain that are less financially motivated? So it's two core problems. One is that, what exists within financial products in blockchain on-chain is very limited. Secondly, there are very, very few really successful non-financial or less financial products in blockchain. And I think the fundamental thing that you can say about the industry is that there's a billion L2s to Ethereum. There's Solana, there's Sui, there's Aptos, there's Move, there's a whole bunch of things. And a lot of people have really focused very heavily on basically improving the ability of a chain to do more transactions. That's what Solana is. It's like basically Ethereum, reduced validator set, bigger validators, way more transactions more quickly. But that model of just basically increasing throughput, it hasn't yielded really many very interesting new products. Yeah, maybe you got pumped up fun, but it's basically a way to to financialize a following or a group of people by launching a meme coin. Meme coins essentially are a social thing where they go up if you think more people are going to buy them, and they go down if they don't have the social capital to succeed. And basically that became a cabal, and we saw what happened with that. It's not really an interesting financial product. It's basically a form of gambling. I'm really interested in financial products. So to cut a very long story short, it's like, okay, we've focused on throughput, great. Hasn't yielded fantastic results, to be honest with you. And what we think at Flare really matters for the next phase of blockchain and more products, and especially as institutions come in, is the ability for people to be able to express things on blockchains, expressibility. I am an entrepreneur. I have an idea. Can it be built in a decentralized way? Well, today, actually, if you sit and think can I build this product that I would like to build in blockchain, and can that product not have hugely centralized components? 90% of the time, the answer is no. And Flare 2.0 is just about converting that to a yes. And it's very fundamentally heavy on, we've got the data, with protocol managed wallets, we'll have the access to all the tokens. Flare 2.0 is about compute and being able to give people the ability to run in a truly decentralized way, basically any program they want that is not constrained by blockchain's limitations with compute. So it's kind of setting the scene for Flare 2.0. Hope that makes sense.
Interesting, really interesting. And Hugo, if you could try and maybe enlighten us on so what you see as part of Flare 2.0, maybe more from a technical standpoint. So if we dive into some of the components that you would consider, for instance, I would say clearly, protocol managed wallets, but also the whole trusted execution environment on all the opportunities that lies there, together with the staking platform. These are some of the core components, as I understand, of 2.0, Flare 2.0, but do you see more to it, or could you put some additional words on this?
So I think let's try and cut this into what is Flare 2.0, what are the elements of it, and if fundamentally the staking product is a product that will be built primarily on Flare 2.0, although it will be built on Flare 1 because they want to get it out ASAP. But it'll have to make some compromises for Flare 1. It'll be less, they won't have to make those compromises as we have protocol managed wallets. So look, Flare 2.0 is about how we use TEs. Two things are going to come out of that. Protocol managed wallet, which is a particular application of TEs, so that a protocol on Flare can manage funds on another chain. So literally the output of a protocol can manage funds. Like I go to a protocol on Flare, I say I want to do XYZ, that protocol can then go and execute it for me on another chain. And that can get very, very, I can say many complex things. Like I can say, let's say that protocol is managing XRP and it's also managing a Bitcoin wallet. So it's got, users have deposited large amount of XRP and users have deposited large amount of Bitcoin. Let's say that protocol is a lending protocol. So traditionally, you would bridge those tokens and then put them into a lending protocol. And that will still happen. People will still be bridging F assets from XRP and Bitcoin and Doge and other tokens from other networks, smart contract networks to Flare, and using them in Kinetic in the traditional way. But protocol managed wallets, just as a concept, gives you an idea that a protocol can manage those funds directly on another chain. Now, they may choose to take the token instead, the wrapped representation, but they don't have to. You could create a lending system for XRPL against RLUSD directly between XRP and RLUSD using a protocol on Flare with protocol managed wallets. Protocol managed wallets is the first protocol that will come out of our Flare 2.0. The second protocol is going to be around compute. Protocol managed wallets are a form of compute, but they're not a rich form of compute. They do a very specific thing. They allow a TE to hold a public key. They allow a protocol and Flare's validators to sign the output of what has happened on the network and send that to the TE. The TE can then process that and sign based on Flare's consensus. This is critical to understand. Protocol managed wallets allow us to basically apply Flare's consensus to execution of transactions on other chains. They're kind of like the first step towards large, interesting things you can do with compute. They're like the most urgent step in terms of things you can do with compute for Flare. But the next iteration is, okay, what more can we do with compute? I want people to be able to build basically anything they want and to be able to put that in a set of TEs that are safe and for a protocol on Flare to be able to call on that compute. And that's kind of where we're going with the next phase.
Cool also. So, okay, so I think we should maybe wrap up this session here around Flare 2.0, maybe just with one question. So would you be, and this is actually a question from the community, would you be like announcing a Flare 2.0 roadmap so we can actually look into what it entails on a longer term?
Well, we've announced Flare 2.0 Part 1, which is protocol managed wallets. When we have a clear view of compute, then there will be information on Flare 2.0 Part 2.
All right. Okay. Great. But yeah, I think we have a lot of on the program today. So let's move on to Dinesh. And Dinesh, could you introduce us and maybe get us a better understanding of trusted execution environments?
Yep, sure. Thanks, Dan. Yeah, so understanding TEs is critical to understanding Flare 2.0. So we can start with like, what exactly is a TEE? So at its core, it's basically a secure area of a modern CPU and GPU. And it gives you a couple of properties that make it very unique. And there are three main properties. So the first is isolation, second is verifiability, and the third is confidentiality. We can break kind of each of those properties down. Isolation means that even if the rest of the system is compromised, data and processes that are happening within the TE are isolated from that. The second is verifiability. That means that the TE can generate a proof that a certain computation happened. So there was some input, some computation happened on that input, and it generated an output, and the TE can prove that that exactly happened. The last one is confidentiality. This means that no one, not even the person who's managing the TE or the cloud provider that's hosting it, can actually see what's happening inside the system. So it gives you confidentiality. And these three properties sort of make TEs very unique in this space. And you can't really get this entire set of properties with the level of performance with any other compute solution out there. So one can then ask the question, okay, we have TEs. Now, why do we need them in blockchains? So Hugo already touched on this. Blockchain scalability has fundamental limitations to it, right? To take a simple example, right? You can't do floating point operations on Solana. You can't do them on Sui, and you can't do them on Ethereum or any blockchain that exists. Floating point operations are the basis for any artificial intelligence model that you want to run. If you can't do those operations, you can't do any form of AI, right? So these blockchains are fundamentally unsuitable for performing complex computation, right? So does that mean that we entirely give up on complex compute? Well, not really. What we need to do is go back to using blockchains, what they're good for. Blockchains are good for having consensus, decentralized consensus on a small piece of state. So the case here would be that I perform my computation off-chain in a TEE, and I post the verification of that on-chain where it gets verified by the decentralized consensus. And this is the true power of blockchain over here. So this all sounds good. You know, TEs sound interesting. They sound powerful. But why are we using them just now? You know, like haven't TEs existed for some time? And the answer is yes, they actually have existed for some time. For example, every time you unlock your iPhone, you're actually using a TE that's located inside the phone somewhere, right? All of your biometric information is stored inside this little chip. And this chip is isolated from the rest of the system. And Apple did this so that even if the rest of your system is compromised, your biometric data, your most personal data, doesn't actually get leaked if the rest of the system is damaged in some way, right? So this maybe somewhat naturally leads to the question: can you just take TEs and stick them on any blockchain and get like good results out of it? And the simple answer is no. And there's a phrase that comes to mind, which is garbage in, garbage out. If I put bad data into a TE, it doesn't matter what kind of isolation, what kind of verifiability, what kind of confidentiality properties I have, I'm going to get a bad output, right? So I need good data. I need high trust data, right? High integrity data to go into my TEs. And it just so happens that Flare has spent a good amount of time thinking about how to build high integrity data. So we have enshrined oracles, the FTSO, the time series oracle, and the FTC, the data connector, for getting a time series data, so prices, for example, that change with time, and also the state of other blockchains as well. And this high integrity data, when you combine it with complex compute realized using trusted execution environments, with the guarantees of isolation, verifiability, and confidentiality, that unlocks some of the most interesting use cases in the space. And one example of that is protocol managed wallets and the more general compute that Hugo was talking about earlier.
Wow. It really sounds like a powerful technology, this, and we can only imagine what kind of use cases, even real world use cases that can utilize this technology. So maybe Hugo, you could put some words on how Flare is integrating with the TE environments that's clearly used for Flare 2.0.
Sure. So there's going to be three layers to this. So the first is protocol managed wallets. The same protocol we use for protocol managed wallets will also allow us to make our data protocols real time. We'll be keeping the FTSO as it is. We'll be keeping the FTC as it is. But we can also add real-time prices, real-time Web 2 proofs, real-time Web 3 proofs. And this is quite cool. And then the last phase will be verifiable compute, which we are kind of working on in terms of the thesis behind how we wish to implement that. There's like lots of ways we could implement it. For instance, we could put an entire blockchain in a set of TEs. Is that useful? Not sure. Could be used as a universal L2, but I'll come back to that in a second. So let's just like focus on protocol managed wallets. What are they? So you want to be able to, going back to what Dinesh said and what I said earlier, a TE can hold, it can do computations on memory with confidentiality. It's secure. The rest of the system can't attack it. This is a really nice sort of aspect of TEs, which allows us to use a TE to hold a private key. So TE can generate and hold a private key with no one being able to see that private key. The TE can then run code in order to allow it to use that private key. And the code that the protocol managed wallet, TE, will be using will be code that allows it only to use that private key for a defined operation signed by Flare's validators. So using Flare's consensus. So Flare's consensus gets relayed to a TE, it processes that set of signatures, all of Flare's validators, needing a majority of Flare's weighted stake. The TE knows which validators should sign and what weight each validator has, and then it can use its private key. Now, having one TE is insufficient because you could have a liveness problem whereby that TE goes down. There could also be, TEs come from manufacturers like Intel, AMD, and those kind of entities. Intel could have made a mistake in creating their TE. So the way we're going to implement protocol managed wallets is we're going to have a set of many TEs. We think currently around 10. That set, let's just take Bitcoin as an example. That set is going to generate private keys for a multi-sig wallet on Bitcoin. And it's going to, that set is going to be such that no one manufacturer and no one geographic location can control the signing on that multi-sig wallet. So what you end up with the protocol managed wallet scheme is essentially a very safe way to exactly execute a transaction from Flare confirmed by Flare's consensus, so directly secured by Flare on Bitcoin, on XRP, on Doge. And if you take the XRP case, it can be a wallet that can use XRP, it can use RLUSD, it can use any of the issued tokens on the XRP ledger. So this wallet, essentially, you can think of it as like, it could respond to a smart contract. It is as close as you can possibly get to being able to really use a smart contract directly on that chain. And so we're going to build, I'll come to use cases later, but obviously Assets V2 is going to basically be using protocol managed wallets. But we could go the other way as well. We could actually, for the first time ever, in a decentralized and trustless manner, issue tokens onto the XRP ledger. So if you're an institution that wants to issue, let's say, an equity or a bond or some kind of representation of ownership, you could do that, and you could have that secured by Flare and issued onto the XRP ledger through that protocol managed wallet. So that's protocol managed wallets. And then how can it improve Flare's existing data protocols? Well, in order to understand this, you have to have a bit of an understanding of how Flare's existing data protocols work. But let's just take the Flare data connector as an example. The Flare data connector asks our validators to basically prove some piece of information. Let's just take an example of what that information is. It might be, I would like to prove that this transaction happened on the XRP ledger. And this transaction is from Alice to Bob of 50 XRP. And it happened in this block, and it has this transaction reference. And each one of our validators goes and pings a node on the XRP ledger, or runs a node on the XRP ledger, finds that transaction, sees whether it's true or not, and then basically votes on that transaction with their weighted stake. Now, at the moment in the FTC, that's happening every 90 seconds. I believe it's 90 seconds. With a TE, the reason why that's happening with the FTC every 90 seconds is that we have network communication overhead, meaning in order for us to communicate the request and get the answer back, 90 seconds is sort of fairly good for a blockchain. We could do it faster. We could probably reduce it to something like 30 seconds, but you wouldn't want to go much below 30 seconds. Each of the validators has to kind of sign it, and then they have to essentially come to consensus over the set of signatures. Are there enough signatures that we can say this information is true based on the weighted stake of Flare? Now, because the protocol managed wallet is going to know who the signers are of Flare's validators, it knows the validators, it knows their stake. This is called a signing policy. The protocol managed wallet knows what Flare's signing policy is at any time, and therefore, if we need information immediately, someone can submit a request, validators can go and get it, and they can report it to the TE. And once there's enough signatures assembled in the TEE, that can then be a proven piece of information on Flare. This we can do for both the FTC and the FTSO. And ultimately, TEs can be really, really fast. And depending on how quickly the validators get the data, which can also be extremely fast because it's just an API call, we can essentially get data in as close to real time pretty much as possible, both for Web 2, Web 3, and price data. So that's like a massive improvement. And then lastly, the integration with verifiable compute is an open question as exactly how we want to design it, exactly what it does. One of the reasons we held the AI Hackathon with Google recently was to see what people wanted to build, to see how they wanted to build it, and get some insights from real developers as to, okay, how are they going to use TEs? What aspects are valuable to them? What aspects are not valuable to them? Do they want a blockchain in a TE? Or do they just want to be able to do compute? These kind of questions are the things we're answering. So, that's where we are today. Protocol managed wallets, improvement to Flare data protocols, very fleshed out. We have an internal roadmap for that. Verifiable compute. We'll be starting with verifiable compute with some bespoke use cases that we're working on with partners. But we're very interested in building like a broader verifiable compute offering. So I hope that makes sense.
It does make a lot of sense. It's definitely really interesting that it seems that we can now really start to scale up and do interoperability in a completely new manner between our blockchains. So that's really fantastic. When we talk about,
I think I just want to make one point on that. I think like interoperability is like one thing, and like we all have this like thesis on what interoperability looks like. I'm interested in interoperability, but I'm much more interested in not having to think about interoperability. Like,
Right.
and that is chain abstraction, right? Like, the protocol managed wallet gives you the ability, gives a developer the ability to build a protocol that holds balances on any chain that the protocol managed wallet exists on, and for some change or output of that protocol to in some way alter those balances. And from a user's perspective, they're just using an application on Flare. They don't need to think about XRP or Bitcoin or Ethereum or Solana or Sui or any of these things. It's they just need to use the application on Flare. Maybe at the beginning they needed to deposit some XRP or some Bitcoin or some ETH or whatever it is. But once they've done that, they can just use that application on Flare. They barely need to touch those, blockchains at any point, and that allows those blockchains to hold those assets. It allows Flare to create a very useful chain abstraction for those users.
Yeah. And that's definitely powerful too. And yeah, it also sounds it basically sounds more useful than actually interoperability, because as you said, Hugo, you don't really have to consider what chain you're on.
Well, it is a form of it. It is, of course, a form of interoperability. I think it's just that I wanted to highlight that most people think about interoperability as some form of token bridging. And I think that protocol managed wallets can potentially lead to a much stronger form of interoperability, and that stronger form is chain abstraction.
Yeah, good point. Very good point. All right, let's move on to some of the questions from the community. We have a question here related to AI and how AI is going to develop with trusted execution environments, and also, if you could put some words on how you see the sort of virtual roadmap with AI and trusted execution environments on Flare network, of course.
Yeah, I'll let Dinesh chime in on that first, and then I'll pick up anything that I think that's missed.
Thanks, Hugo. Yeah, so I think AI is one of those use cases which really demonstrates the true power of TEs. Because if you take any other compute mechanism that we have available today, if you take FHE, MPC, ZK, none of them can do what TEs are able to achieve, right? You're talking about performance differences at the minimum 100 times worse, and generally close to 1,000,000 times worse. So this is a use case that sort of truly highlights how powerful TEs actually are. And that was one thing we had in mind during this Flare X Google Hackathon, is to explore this boundary. What is the intersection of blockchain and AI? And what is the point of that intersection that actually makes a lot of sense, that creates value for the end users? And I think we had some really interesting submissions, and we'll probably go into them later on this call. But in terms of like a vision for AI, the hackathon basically marked the kickoff of something called Flare AI Kit. Now, Flare AI Kit is an open source SDK for building verifiable AI agents. And I'll discuss maybe a bit later why verifiability is so important to what we're doing with AI. But all of the top projects that won prizes at the hackathon are going to be basically fast-tracked into Flare's grants program. They'll be working both on their ideas for what they're implementing to build them into finished products, as well as work on components of the Flare AI Kit itself. And there are primarily 4 components. There's a social AI agent, which is interacting with things like Farcaster, decentralized social media, X, Telegram, and so on. There's a RAG component, which is the knowledge pipeline, how it gets information from Flare, let's say the blockchain, the documentation, the community, governance proposals. There's consensus learning, something that we're very excited about. There was a white paper published some time ago, which detailed how you can use a set of models to come to a better aggregate result than any individual model by going through the process of consensus learning. And there's also then DFAI, which allows you to abstract away a lot of the complexity inherent in DeFi ecosystems using a layer of AI agents in between. So this is kind of the idea that we're working towards, and this will be the main focus of the Flare AI kit.
Cool, really cool. And I guess we are also going to touch about a little bit more upon this when we get to the last part of the call. Just to Hugo, you had a few words you want to say on this topic here now?
I think Dinesh covered it incredibly well. I mean, I think I think there's myriad opportunities in AI with blockchains. I'm not sure, as yet which are going to win. There's obviously been a lot of hype around AI agents. I think that they're very interesting in terms of being able to, mostly make using blockchains a hell of a lot easier for people. So just use plain text in large language model. You say, I want to convert my whatever token I have to this other token. I want to do the best price, and I want to do it, on this particular set of chains. Find me the best protocol, and at the moment, assemble me the best transaction. You wouldn't want an AI agent to do a transaction for you these days because there are two reasons. One, whatever agent you're using should not be holding your private key, and two, you don't know whether that AI is safe. Like one of the key things we're trying to do with the Flare AI kit is to give verifiable AI. So today's AI agents, you go use them. They say they're using some kind of model. How do you prove that? You can't. It's difficult to know what's being run on a centralized server because an AI agent has to be run in a centralized server today. So you don't know which model is actually being run. You don't know whether the AI agent has been corrupted in some way, such that it gives you a suggested trade that is in some way beneficial to the owner of the AI. Maybe they've got a large position in a pool somewhere, and you're being used as the other side. And so one of the critical things we're doing with Flare AI Kit, I think, is the ability to use AI confidently with a blockchain by being able to verify that a particular set of code is being operated. And that's one of the key things of trusted execution environments. You can verify that the code that you think is being operated is in fact being operated. So that's key. Anyway, I'll leave that there.
No, but it's very interesting, very good points, and definitely today's AI agents that's a lot of trust you have to put into those. That's for sure. All right, I think just if we can shortly, just as one more question here, if we can shortly just put some words on, how these trusted execution environment providers, how are they actually rewarded? How are they paid for their service in this setup? Can you put some words on that?
So this is a community question, right?
Yes.
At the beginning, Flare Foundation is going to run the trusted execution environments. Again, we can't see into the trusted execution environments. We can't extract the private keys. This is the whole point of trusted execution environments. And we're thinking about how we decentralize that. We do want to decentralize it, but we also don't need necessarily 100 trusted execution environments. We have about 100 validators. We don't need every validator to be running a trusted execution environment. We also don't, it would be an expense that is unnecessary. Trusted execution environments are not inexpensive to run. We also don't want some validators to run trusted execution environments and get paid for it, and others not to, because this then creates an imbalance in the economics of being a Flare validator. So at the beginning, we're going to operate the trusted execution environments, and we're thinking about, okay, how can we allow the trust execution environment to be decentralized in a way that doesn't compromise the economics of being a validator. That's a slightly more long-term plan. We want to get out with protocol managed wallets to begin with. Really, the only risk to us running the trust execution environments is that we would turn them off. And even then, under the protocol, they can be recovered and set up by anyone that wants to set them up. So that's there's no risk to us running them, but we do want to decentralize them. We just don't have we don't have a methodology to do that currently.
All right. Okay, great. Thanks for the answer. Let's move on. Let's jump to the next topic, and that's having a closer look at the protocol managed wallets. And I guess, Dinesh, how do they actually work? We have been touching upon it, but maybe you could put some few more words on how the PMWs simplify building on Flare for developers.
So as Hugo mentioned, PMWs are a way to extend Flare's consensus to other networks. And to kind of understand how PMWs work, you need to understand a little bit more about what makes Flare sort of special. And one of the things that makes it special is the Flare systems protocol. And you can think of the Flare systems protocol as like a connective tissue between Flare's consensus and its enshrined data protocol. So that is currently the FTSO and the FDC. And what the FSP does is it makes use of the existing set of Flare providers. So in the protocol managed wallet, the Flare blockchain, it acts like a synchronization and verification layer. So the way that it will work is the TEE will try and onboard to the network. And the way that they'll onboard is they will submit a remote attestation to the FDC. A remote attestation for a TE is a proof that looks over all the hardware and the software that's running in that system. It covers basically every piece of information that is relevant. And the FDC is going to verify this particular proof. And if the TE passes this test from the FDC, it's going to add it into a smart contract. And the smart contract will live basically on Flare. And once a TE gets added to a smart contract, users can now interact with it. So a user, for example, can go to the smart contract, they can give it some instructions, and these instructions will be picked up by the data providers. Then the data providers will sign this instruction and they will send it to the TEs. And if there's a stake-weighted majority of weight behind that instruction, then the TE will execute that. So that's sort of at a high level how the FSP sort of interact and the FDC together with the PMW work to make the system run.
Awesome, cool. Okay, so yeah, we actually have quite some questions from the community. I think we should start covering. How about that?
I mean, we could do that, or we can run over, TE use cases, or I don't know.
Yeah, that's also an important one, of course. Maybe you can take that, Hugo, and go into the use cases we have for protocol managed wallets.
Yeah, sure. So, I mean, obviously, we're going to build Flare's F Assets V2 using protocol managed wallets. This is going to be like F Assets, but without agents. There'll be a staking protocol, so people can stake to the F Assets protocol. It'll be a form of insurance. Not that I think there will be any need for insurance, but it'll allow you to participate in the yield that the bridge creates, i.e. there will be a fee for transactions, minting and redeeming, and those that stake their tokens to F Assets V2 will participate in that fee along with the providers of any non-Flare operated protocol managed wallet TEs. So that's the first one. Then of course there's staking of XRP. this is a huge protocol being built by a very interesting partner. This will allow XRP to be staked to various protocols that want to leverage that stake for security or potentially liquidity. So to give you an example of that, let's say you want to create an Oracle network, or let's say you want to secure the TE network in some way, and you want each provider of the TEs to be penalized if their TEE goes offline for any reason, right? Like, we want the TEs to be available for use all of the time. We don't want them to go offline, and so one of our ideas about how to decentralize those TEs would be allowed to allow people to stake Flare and stake XRP to them, so that they ultimately there's some penalty for a loss of liveness, and of course, in return for the staking rewards, in return for staking, you would get some of the fees that the protocol managed wallet TEE earns by participating in protocols. So one of the protocols that's going to participate in is the F assets, but I foresee many protocols leveraging protocol managed wallets. So let's run through what some of those protocols do. So for starters, the protocol managed wallets gives you essentially as close to full programmability for Bitcoin, XRP, Doge, and those kind of things. Give you a really example, just a super simple example. Let's say there's an AI operating in Flare's compute environment. It's an AI agent. It's just you can use that agent for sending XRP or Bitcoin or Doge to a friend with a simple one-line send some money to Bob. That protocol would be executed through Flare's protocol managed wallet, and protocol managed wallet would charge a small fee for executing that, and ultimately that if you were staking to the protocol managed wallet TE provider, you would earn part of that fee. So then there's things like cross-chain lending. Imagine, as I said earlier, you've got pools of capital on various different chains. You don't need to bridge that capital. There's no particular reason why you would need to bridge that capital if these protocol managed wallets exist, because Flare's FTC can report to a protocol. Flare's data connector, the Flare data connector, can report to a protocol on Flare how much is in each wallet and how much relates to each protocol. And ultimately, because we have the FTC and because we'll have protocol managed wallets, like the need for bridging is reduced. So a lending protocol could be built, say, on Flare that allows you to manage multiple pools without having to do the bridging. Again, deposit Bitcoin, XRP, USDT, Ethereum, really any asset on any chain, and from one of those chains you can borrow one of those assets. Kind of very, very interesting. Then once you pair the protocol managed wallets with off-chain compute, you can start to do things with AI, with risk models. One of the reasons why blockchain has suffered in terms of product mix, in terms of what people are building, is because if you look at TradFi, products rely on really, really deep, complex risk models. And that doesn't exist in blockchain. And imagine you're running a really good risk model in a TE, then any protocol could potentially tap into that risk model and say, I've got these assets, someone wants to, lend me X against these assets. The collateral they want, which, might be Bitcoin or might be XRP, can you analyze its volatility and tell me how much I should charge to ameliorate the risk of lending against this asset? And so you can start doing much more complex financial transactions once you've got protocol managed wallets using the FTC, the FTSO, and off-chain compute. So I think that can leave that there.
Interesting. Really interesting. Could we go into some of the more, there's some very concrete questions from the community, for instance, also related to the original F asset design and the V2 design. So now we will soon be releasing, or Flare will be releasing version 1.1 on Songbird. And I believe I also heard that actually on version 1.1 there will actually, it should be able to do unlimited minting, which is also what we aim at for 2.0. But can you explain where you see the differences between 1.1 and 2.0?
Oh, absolutely. So 1.1 will keep the agents, but it allows the agents to move their position to a safe intermediary. It's detailed in the 1.1 paper, and that 1.1 paper will come out shortly. You will notice from that 1.1 paper that it's not a different protocol to version 1. And you should be able to draw conclusions as to what that means with regards to the time frame it's going to take us to release it. If you can't, I can't help you. But ultimately, 1.1 will allow agents to essentially send, if you think about how version 1 works, agents put up collateral, they receive the underlying, let's say it's XRP, and they have to maintain their collateral against this very large amount of underlying. When we designed version 1, DeFi basically hadn't really taken off. And what we found when we tested version 1 on Songbird was that ultimately the yield that the bridge creates was not competitive with the yield across DeFi ecosystems, so we can't amass enough stablecoin collateral. So we want to figure out, okay, how do we ameliorate that in a way that we feel comfortable launching the protocol and allow the protocol to do very, very much larger amounts of minting. So we've created what we call a core vault. Core vault will allow agents to move their position to that core vault, which frees up their collateral so that people can mint more against those agents, and then they can get that collateral. They can get the underlying back when they need it. So essentially, the core vault is a liquidity provider to agents in the V1.1 system. The V2 system will dispense with agents and collateral entirely and just use protocol managed wallets.
All right. Okay. And so in the 2.0 version, are we looking into more different kind of collateral tokens, or will it actually only be, for instance, the native in case with the XRPL? Will it only be XRP used as collateral, or will it still be some mix?
Well, XRP is never used as collateral. It's the bridged asset, right?
Mm-hmm.
The collateral is the underlying asset, is the asset on Flare, USDT and FLO. There won't be any collateral that's needed for bridging in Flare F assets V2. What there will be an insurance pool that allows those that send their, let's say, wrapped Flare in this instance, to participate in the earnings from the bridge.
All right. Okay. So the community will still be able also to place collateral with agents pools. How does that work?
There won't be agents in V2. It's just the protocol managed wallet just handles the cross-chain component. Protocol managed wallet receives XRP, it's a set of smart contracts on Flare. FTC reports to the smart contracts on Flare how much XRP it has received and what address it needs to go to. That contract mints FXRP, sends it to the correct address. Protocol managed wallet holds that XRP safely, when someone wants to return FXRP to the F-Asset V2 contract, they just send it to the contract with a memo field telling them what address to send it to on the XRP ledger, and then Protocol Managed Wallet can execute that and send that XRP back on the XRP ledger to whoever, whatever the deposit address was. So that's very simple. There's then an insurance protocol that allows people to essentially stake their FLR and earn the yield from the bridge. And therefore, whatever the bridge is yielding, that will dictate how much FLR is staked to it.
And can you put some words into what kind of rewards people will be, what kind of tokens they will receive as rewards in a F-Asset version 2 setup?
Well, they would receive whatever is being bridged. So, if they're staking to the Bitcoin version of F-Asset, they would receive it in F-Bitcoin. They're staking to the XRP version of F-Asset, they would receive FXRP.
Great. Awesome. All right. Okay. So let's move on to some of the other questions we have here. Let me see. That's a very common question we all always get on these calls. And can you maybe reveal a little bit about when we can expect F-Assets version 1.1 on Songbird?
Nope.
That's a very short answer.
Nope, absolutely not. Read the paper, figure out how different it is from the existing V1, and then draw your own conclusions as to when it'll be deployed. I don't want to make that mistake again.
Okay. All right. Good. Let's move on. Let's see if we have more to cover here. Yeah, I think I have another interesting question here. So when we talk about the staking platform, that will be used for these actively validated services, right? And it could be very interesting to hear about if you could give some examples of concrete AVS services in Flare Network where there will be some demand, and in what domain you think that will basically flourish first of all.
So with the Protocol Managed Wallets, this AVS doesn't need to be on the Flare Network. It's great if it is. It doesn't need to be on the Flare Network. In fact, we're talking to a number of protocols that are built on Ethereum that are interested in having people stake their XRP to them because those protocols want the maximum amount of security. In order to understand this, you have to understand how proof of stake works. Pretty much everyone in the Flare ecosystem is using proof of stake. They're staking to either a validator or that validator's data provider. So they're either staking FLR on the C chain in order to give that validator's FTSO voting power within the FTSO, or they're staking on the P chain in order to give the validator directly the delegated stake. There are literally hundreds of protocols, maybe thousands now, of L2s, even L1s that require security, want security, want more stake. They want more stake delegated to their validators. And they want that stake in multiple types of token. So some of them want it in Bitcoin. Others, because there's no yield in the XRP ecosystem currently, there's no staking yield. They, A, want to be able to provide XRP users with yield, but B, because there's no yield, the security that is conferred by having XRP staked is cheaper for them than having another token staked. So to break that down, if I have an asset that has a natural yield of, let's say, I can go and put that asset in a lending protocol and I can get a yield on it of 10%. But I'm looking at XRP and it's got $128 billion of value or whatever it is today, but it doesn't have a yield. I can't put that XRP anywhere and get a yield for it. Therefore, people will accept 7% on their XRP, let's say. And relative to the 10% that other token requires just to get it out of the staking protocol, the lending protocol, XRP confers the same dollar value of security at a lower price. And this is the opportunity that I think is very exciting for staking through Flare. We're talking to a number of protocols. I can't give you their names until they announce, but they're very interested in increasing their security by having XRP staked to them because it's less expensive and comes with a big community than it is for them to go and ask someone to stake, for instance, Bitcoin, which does have a natural lending rate in the market. So I hope that makes sense.
Yep, that's great. All right, so yeah, I think we are almost, at least from a question perspective, we're almost ready to move on to the next session here, the last one. Just one question, maybe, Hugo. Can you reveal who is actually the partner who's building the staking platform for Flare? Or when will you reveal that? I think a lot of people are interested.
I'm not revealing that. They will reveal that. I'll let them choose their timing as they wish.
Okie dokie. All right. Okay, so let's move on to the next one, and let's talk a little bit about Flare and the Google Cloud Hackathon. We already touched a little bit about it and touched about some of the points, some of the submissions, and but maybe you could talk a little bit about what is the nature of the relationship between Flare and Google Cloud here in this context, and yeah, I think a little bit more about how you prompted this collaboration.
Oh, sure. So I mean, Flare's been a partner of Google's for a year or so. Google a partner of Flare. I think maybe a year and 3 months. They run a validator, they run an FTSO, and we were just chatting with the Google team, and we've always been interested in machine learning. I think many of the people on our team have a very strong understanding of machine learning if they don't actually have an accreditation in machine learning. So it's always been on our roadmap, and we were talking with the Google team, and we've been thinking about TEs for a while, and I think that we just suggested the hackathon, and they're interested in seeing how people use confidential compute, which is their word for TEs, and we thought it was a good time to put something together. They don't usually run hackathons with people. They certainly don't usually, when they have a business relationship in London, send a team to San Francisco and do that kind of stuff. But I think they thought it was a very interesting set of use cases, and I think the hackathon went very well.
Yeah, sure it did, and there was definitely some. At least that the winning project, I was looking into that, and that's definitely an interesting one. I don't know if Dinesh, maybe you want to put some word on that.
Yep, sure. So the project that won the IRL hackathon track was called 2DeFi. And the goal of 2DeFi is to basically simplify the TradFi to DeFi transition. So what you can do with 2DeFi is you can take a screenshot of your Robinhood or Fidelity stock portfolio, and then send that to Gemini 2.0, which uses multimodal AI learning to figure out what is your risk tolerance. So it looks at things like, okay, are you holding just SPY in your stock account? Or are you holding a mixture maybe of NVIDIA and Tesla, right? And it uses that to gauge what is the risk tolerance of that particular user. And based on this, it comes up with a risk metric that maps to a DeFi strategy on Flare. So for example, if you are just holding SPY, you're probably low risk, right? So maybe you only want to participate in staked Flare, right? But if you're holding NVIDIA and Tesla, that indicates you're open to a little bit of additional risk. So maybe then you're providing liquidity on SparkDex. So on and so forth. Basically, you can create this very seamless transition from traditional finance to DeFi. Another project that I think is actually quite interesting is something called Flare Fact Checker. So Flare Fact Checker, the project that is, it's a decentralized and verifiable fact checker for social media platforms. And they integrated the project into Farcaster Frames. So Farcaster is decentralized social media. And a user on Farcaster, if they see someone is making a claim, they can make a request to have the post fact checked. And what this request does is it gets raised on the Flare blockchain, where there's a set of verifier nodes which are running in TEs. And these verifier nodes have their own internal databases. So they have their own internal data sets. And they will validate this request. They will check to see if this request is factual against their data. At the end, then there's an aggregator TE, which will combine all the results from the different verifiers, and it will come to an answer as to what the truth actually is. And this final response is then posted on chain and is posted back on Farcaster. And they actually use some pretty advanced mathematics. They used Shapley values to calculate rewarding for the individual verifier nodes to see who gets more of the pie and who gets less. So yeah, these were two really interesting projects. There are a lot of good submissions. We just have time to highlight two, but these are two that I found really interesting.
Yeah, it's definitely interesting, and I think you can, but when you look at these submissions here, it's clear that you can really start to see how this is forming into some useful AI technologies that can be used also. As I mentioned before, I'm starting to think now that we can use this in more real world use cases, and also in terms of what is that? That it can be used for more broader TradFi integrations going forward. All right, so I think, yeah.
No, nothing. I thought that was the question. No worries.
We have actually already crossed 1 hour here. Yeah, we have covered all the areas so far, and we have also covered a lot of the questions from the community. So, yeah,
so we open it up to some community questions.
Yeah, that would be a great idea. Let's do that.
Let's do it. Let's do it. Put your hand up or request to speak. Let's go. HP Supreme.
Hey, buddy. How you doing, buddy?
Hey.
How's everything? Good?
Yeah, good, thank you. How are you?
Good, good, good. So you might have said this, but, all these, tech words and stuff like this, I just had a question. And once again, I appreciate all the stuff you guys are doing, because I know how hard it is to build a business. And, I have respect for anybody. I know it takes time and all that. So I just want to say that. I just have a question. My question is, right now I'm staking, and I know I'm doing it with Bitfrost, and I know that has nothing to do, that's a different platform. But my question is, what is your plan? Because averagely we receive around 2.7 monthly. What is the plan after January when it comes to staking APY? Because my understanding in my mind is, I think that brings a lot of sell pressure a lot of times. And when you have something a little more realistic within like 3 to 5 or maybe a little higher, the sell pressure comes kind of down. So my thing is, after January, after we stop earning all that, from delegating and wrapping, what's the idea for that? And, so maybe it doesn't also create a lot of selling pressure, because I have yet, being in the space, met a protocol that gives so much APY, but basically, it affects the price, if that makes sense.
Sure. After January, Flare becomes a very low inflation, pretty low inflation coin. I mean, we're starting at 5% and trending towards 0. People seem to like low inflation coins. And of course, the more demand there is for Flare, and the less inflation there is, I think that's interesting.
Okay. All right. Thank you very much. I really appreciate it. That's all I had. And like I said, thank you guys for everything. Okay.
Thank you. I hope that makes sense.
Yeah, it does. It does. Thank you.
All right. And actually, yeah, do we have more questions out there?
Yep. We got PJMJ came up as a speaker. I don't know if he's going to come off mute. No, not sure.
All right.
Well, guys, just so active in the comments. Let's get some stuff said.
I also actually I have one more actually interesting question from the community that might not be much to it, but I think it's interesting to ask anyway. So there's actually a question about when the distribution period ends in January next year, whether there's actually any plans to restructure the revenue generation model. So like, did you think about actually creating some kind of treasury where revenue would go into, so it could be distributed? That's actually a question from a community member.
Sure. I mean, it seems a little vague in terms of both the question and perhaps like the substance. But how do I put this? The revenue is a thing that protocols earn. It's not a thing that a blockchain earns. Blockchains don't create revenue. Blockchains have tokens. Tokens get used in transactions. On some blockchains, those tokens go to the people that generate the transactions. On other blockchains, those tokens that are used in transactions are burnt. On Flare, they are burnt. If the tokens go to those that process the transactions, then they get distributed unequally. If the tokens are burnt, it benefits the entire community. On Flare, the tokens are burnt. As protocol managed wallets come in, transactions are going to substantially increase, I suspect. One, there will be greater call for the FTSO. Two, there will be greater call for the protocol managed wallets, which is a transaction. And three, there will be substantially greater calls for DeFi protocols, all of which are transaction-based. So there will be a greater amount of transaction fees burned. Couple that with a low inflation token, and I think you've got an interesting sort of economic scenario that will be unfolding.
Yeah, I think that's a good answer, and it's also, I think it's sometimes it's a good idea to remind how this tokenomics actually work in the network. So
yeah,
all good, and I think I think back
Bruce?
to the audience. Any more questions out there?
Watcher Danny, Watcher Hugo, Dinesh, thanks for letting me up to speak. and thanks for holding the space. It's been very insightful. Uh, My question for Hugo is, like, for me as a technologist, the combination of what Flare networks have done with respect to trusted execution environments, abstraction of chain, and alternative ways of interoperability. Like one of the things that you said really resonates with me is that we shouldn't have to think about interoperability, but the way that Flare seem to have been moving in this direction, where it's completely decentralized interoperability, obviating the need with all the problems that comes with bridging. That's incredibly exciting. I'm not sure if people really understand the impact of that. My question for you, Hugo, is like, how does this approach compare with, you must have looked at the competition, you must have been aware of different ways of achieving interoperability, but like, how did you come to actually decide that this set of technologies is so much more advantageous than the competition? And what competition did you look at?
I've looked at, all of them, obviously, and they all have their plus sides, and you know, I think it's less competition than, like, if there was a use case for protocol managed wallets to, let's say, use Stargate to bridge between two chains. Okay, why would a protocol managed wallet need to bridge between two chains? Like, why would a protocol built on Flare need to bridge between two chains? So let's say you have a lending protocol that has a large number of, it's lending out, it's built on Flare, and it's lending out, let's say, some type of stable coin on 5 different chains. Well, it's still going to need a bridge between those chains, because it's got to even up the amount that it can lend on each chain. It's got to rebalance. Let's say on Ethereum or on an Ethereum L2, it lends out all of the funds that it has available, but it has a large amount of funds elsewhere because there's an imbalance in the system. It's still going to use bridges. We're not going to build those bridges. Bridges have already been built. They're fine. Some of them are good, some of them are bad. But the protocol managed wallet, what this really gives you is the ability for protocol on Flare to extend across multiple chains, and use a bridge where it is desirable. And Stargate being the most widely used bridge, the bridge with the most liquidity, is the one we're interested in talking with in that domain. And so how does it differ from, say, like other total interoperability stacks? Like Stargate is a bridge. It is not an interoperability stack. Layer 0 is a messaging service. It's not aiming to be a chain, like a true chain abstraction service. It's a messaging service. So I think it differs in that, there are others that are trying to build, maybe these chain abstraction systems. But Flare's is just super lightweight, like in terms of the integration. Just build a protocol in Flare, and you can submit a transaction that can be done on any chain where there's a protocol managed wallet. You don't need to mess around with putting smart contracts on 10 different chains and all this kind of stuff, which is like how the sort of modular approach get where the modular approach gets you. Like other entities, like they're like, oh, we'll do message passing, but then you can message pass between different smart contracts. Okay, so if you want to be omni-chain, you've got to put basically some version of your smart contract to understand those messages on each chain and then take an action. Whereas protocol managed wallet just lets you build one protocol in Flare and manage funds anywhere. And that's kind of, it's just much, much, much easier. It's also more secure in reality. Other, interoperability methods, TEs are superior to most other interoperability methods, with the exception of ZK. Problem with ZK is it's slow. So, really slow. So that's a different consideration. So to answer your question, really, we wanted to have the lightest weight approach that got the most bang for buck, and this is it.
Thanks, Hugo. Makes a lot of sense. I'm really excited about what you're doing, essentially. I think anyone who's building across multiple chains now has a very innovative and unique tool at their disposal. Thanks.
Absolutely. Well, I think the addition then, protocol managed wallets are one thing. Flare has data, so protocol built on Flare can get the data from its protocol managed wallet on another chain. Awesome. But, what really will set us apart is when we have like Flare compute layer. Suddenly you can ingest vast amounts of data and do interesting things with it. So, I come from a background, I studied financial engineering at university. The things that are being done in crypto with regards to the types of products that currently exist are kind of child's play, like de minimisly interesting, like of little interest. As soon as you have compute, you can start doing things that are truly sophisticated and interesting, and that's where institutions will be interested in Flare.
All right, great questions out there, and we have more coming in.
I don't see anyone else coming up as a speaker. We can leave it there.
Yeah.
And I think we should.
All right, but great for all the participation, and thanks for all the great questions and all the good answers from Dinesh and Hugo. So thanks for that. Great call.
Thank you so much. And as it's Friday, I hope everyone has a really lovely weekend.
Thank you.
You too. You too.
Well, guys, there we had it. That is the end of the space. I thought it was all right, to be honest, but if I'm honest, I think you probably get a lot more value from just reading this documentation. It seemed like it wasn't that logically flowing, although Hugo did expand on T's trusted execution environments and also the protocol managed wallets, which is something that I'm particularly excited about. But yeah, it was all right. We didn't get any new information, unfortunately, but yeah, it is what it is. But yeah, that's it, guys. So I would like to thank you all so much for watching. Please don't forget to like and subscribe on the way out. Do have yourself a fantastic weekend, and I'll catch you all in the next one. I'm out.
We have liftoff.